You are watching NetSoft IT Academy. 905-812-2923. info@netsoftacademy.com. www.netsoftacademy.com.
Welcome back to AZ-104 Exam Prep Series. In this video, we are going to cover how to configure and manage virtual networks in Azure. That is a core skill for any Azure administrator. So let's start. All right, so now let's learn something about networking. So in my environment right now, I don't have any resource group, any network, or any resource to prove the point. So we will do it together. So what is virtual network? Basically, virtual networks are software-defined networks. All right, so logics, the software logics emulates what a real network will do. All right, this is what we call it virtual network. So Azure Virtual Network is Azure's cloud software-defined network. Now, when you create a virtual network, Azure creates a network boundary in a specific region. Now, all the resources who use the IP addresses from that virtual network boundary, they can communicate over IP protocols, that is internet protocol, right? They can talk to each other. So we will create some resources and learn these concepts along with it. So I will create a resource group first. I will call it Demo in Canada Central. Done. Now, I will create virtual network. So let's go to virtual network. This is the place where you manage, configure your virtual network, and even decommission it. So click on Create. Then select your subscription, select your resource group, and give your virtual network the name. So first network will be VNets 01. And I will deploy it in Canada Central. Next, no need to add encryption, no need for Bastion at this point, no need for firewall, no need for DDoS protection, but all these facilities, or you can say services, are provided by Azure to secure your environment. Either you can secure your parameters with firewall, or you can securely connect with your resources via Bastion, and there are a lot more features to secure your environment. But let's focus on network part. So the next tab is IP addresses. This is where you create your address space and subnets. Now, Azure already gives you Class A address space, but if you want to change it, you can. So what is address space? Address space provides the boundary, address space provides the boundary of your IP addresses. It tells you what will be the starting address and what will be the last end address. Now, when we create address space in Cisco router or in your home router, every address space will have three things. The first IP, which denotes the network address. And you cannot use it for hosting purposes. It's reserved. So the first address of any range is the network address, which tells the network infrastructure that, okay, which bubble is it, or which address range it is. The last IP address of any address space is the broadcast address, again, reserved. And this is why whenever we create an address space, we always say total number of IPs minus 2 is the available addresses. Available means your host machines or your services can use it to specify their unique addresses. Now in Azure, again, when we create the address space, we do have the network address, we do have the broadcast address, but Azure also reserves 3 more addresses. So in total, in Azure, network address space have 5 reserved addresses which you cannot use. In normal networking, you have 2 reserved addresses. In Azure Cloud Compute environment, you have 5 reserved addresses. So whenever you create an address space, let's say we go with 10.0.0.0/16, you will put the IP address and you will put the CIDR. This is where you define the subnet mask. So if I say /16, that means the first 2 octet is for the network allocation, and the last 2 octet is for your host allocation. And this one gives you 65,536 addresses. Now, subnet. Subnet means subdividing a network into smaller parts. So when you create address space, you don't want to use the entire address space for a specific project. You may want to subdivide it into much more manageable parts. So you create subnets. Subnets give you smaller chunk of the main network, and it helps to enhance the security, and it also helps for easy management of traffic flow. So you can create subnets. Azure again creates one subnet for you, but you can always change it. I will call it subnet. Now, this subnet have 24 as the CIDR. That means the last octet will be used for host, rest 3 octets, the front 3 octet or the first 3 octet is for network. So the last octet gives you the total of 256 addresses. Remember, you have 0 to 255 in one octet. 255 plus 0 is 256 because 0 is also considered a valid number here. Okay. If you want to create more subnets, you can keep on adding. Remember, you can add as many subnets you want, but the limit is the range of the actual address space. So your subnet can be as big as your address space, but cannot go beyond the scope. Plus, if you create multiple addresses, the IP address must not overlap. It cannot overlap. Overlapping means in this subnet you have IP address called 10.0.0.60, let's say. The next subnet cannot have that IP address. It must be the outside the range. Okay, so now you have subnet. One more point. When you want to connect 2 networks together, again, even those 2 networks must have unique IP addresses and it should not overlap. Now, click Review and Create. So my first network is created. I will deploy one more network. Demo. VNet 02. Now, I can deploy this network in any other region. Remember, the resource group is in Candace Central. That doesn't mean that every resource inside that resource group must be the same region. Well, it can be in any region. The only consideration is that all the resources inside the resource group must have a common life cycle, a common vision, or you can say must be a part of a common project. So what if I want to deploy this in, let's go to, no, not Mexico, it's too far. Or why not, actually, let's go to Europe. Let's go to France, right? Click Next, no security, IP address. Again, Azure gave me the same IP address range. If I click on Review and Create, will it actually work? The answer is yes, it will work because right now both networks are totally separate. They are not connected. But in my demo, I will also connect them later. So as a proper network architecture, I have to make sure that they don't overlap. So I will go with class B. How about this? And I will also call this subnet as subnet. Simple. One subnet is enough for me to prove the point. And create. And that's it. Now you know what virtual network is. Virtual network is just a software-defined network which creates a logical network boundary in a region and give IP addresses to your resources so that resources can communicate with each other. So my two networks are ready. Now, I will deploy two machines. Remember, I'm not teaching you how to create a machine at this point, but I will create two machines so that I can show you that the first machine is in VNet 1 in Canada Central, the second machine is in France using VNet 2, and I will try to ping each other. It will not work because both machines are on a separate network and the networks are not connected. So let me quickly deploy two machines now, and then I will resume the recordings. Well, actually, I will also quickly just go through how to create a machine. But hey, don't get overwhelmed. I will show you how to create a machine later as well. So I will go a little bit faster. So I will search for virtual machine, click on create virtual machine, select my resource group, my subscription, and name it VM01, let's say, in Canada Central. Availability, I don't need it. Security can be standard. For operating system, that is image, I will use Windows 10. I still like it. You can also select Windows 11 if you want. Doesn't matter, for this demo at least. The size, I will use DS2 V3, which gives me 2 CPU cores, 8 gigabits RAM, and that is more than enough. Local admin credential. Okay. RDP open because I need to connect with this. Click next. Now, what is NSG? Again, we'll discuss it later. Okay, disk premium SSD is good enough for me. Network, this part is important. So here I will select the network I created. As you can see, I can only see VNet 1. Where is VNet 2? Well, when you're creating this machine in Canada Central, so you will only see the resources of Canada Central, until unless it is global resource. If it is regional, you will not see it. And this is why you only see the network created in Canada Central. This is my subnet, this is my network, and public IP, I will say no, because I will teach you that you can create public IP separately and then connect it with your machine. Public IP just exposes your machine to the public domain so that you can connect with it from your own home, means from public internet. NSG basic RDP open. I will open this port. I need to connect. This is the protocol for remote desktop protocol. But no worries, if you don't pay attention over here. Just the network part. Management, no change. Monitoring, I don't want to monitor anything. Advanced, no change. Tags, and create. It will cost me this much per hour. That's okay. My demo will be shorter than this. And create this. Once you create a resource and it says initializing deployment, don't refresh the page. Once you see deployment is in progress, then you can go ahead and deploy your resource again. That instruction or that template which you created is already gone to ARM, Azure Resource Manager, and it's been taken care of. Let's create one more machine. Demo, VM02 in France, because I have my resources there. France is fine. Availability, I don't need it. Standard security is fine. Windows 10 is good enough. This is good enough. NITAADMIN. Password 1234. Password 1234. I'm using the worst password. For this demo, it is good, but please don't use password 1234 actually for your production. It's not safe. RDP open. Next, disk fine. Networking. Here you go. You have VNet 2 because it is in France. Then you select your subnet, IP address. I don't need it. Oh, why not? Yes, I need it. So to showcase that it is possible to create public IP or to create multiple resources all from one template. So for one machine, we said that, hey, we don't need public IP right now. We will do it manually. And for this one, we are putting it in the template that create a public IP for me. Now you know both ways. Sorry for that. And go to monitoring. I don't need it. And once it is validated, I will click on create. And now I will pause the video. Not really. One of my deployment is done, so I can move along. Oh, no. Both machines are still waiting. So I will wait for this machine. Or in the meantime, why not? I'll show you how to create public IP manually. So if you want to create public IP, just type public, public IP address, not prefixes, because you only need one public IP. But if you need a range of public IP, then select this. I just need one. This is for machine number 02 created by Azure. I will do it for machine number 01 now. So click on create demo in Canada Central, where my machine number 1 is. Name it VM01 IP. Which version you want? I want IPv4, but IPv6 is also available. If you need IPv version 6, then go ahead, select that. For most, I will say situation, IPv4 is perfect. Now, do I need high availability? I don't need it. But Azure offers high availability in many services. High availability means multiple instances will be created. And if, let's say, one zone is down, your service will still be available via another zone. Standard, fine. Microsoft Network is fine. You can also put a DNS name. That means instead of putting IP addresses to connect with this machine, you can actually put a name. And again, I'll show you that. VM01. Oh, sorry. VM01. It's already taken, so it should be unique globally, by the way. How about RSB, my initials? Yeah, RSB VM01. So now I also have a proper domain name for my IP address. Now, DDoS protection. Well, whenever you create it, always disable it. If it is created automatically, DDoS protection is enabled. Why I say disable it? Not because it is mandatory, just because it is expensive. So if you are only learning the network part, well, don't touch the security part. Right now, you are focusing on networking, and I'm going to disable it. And create. Well, my public IP will be created shortly. Let's go to our VM now. My second VM created, done, by the way. But let's focus on first VM. Click on it, and if you want to configure anything regarding networking, then in the VM, go to networking, then network settings. And just like you go to your network configuration of your network card in your laptop or your, PC, here you also go to network interface. So this is your NIC, network interface card. You click on it, then click on IP config, and scroll down, and here it says associate public IP none. Well, I want to connect VM01 IP, the one we created, and save. Now wait for this to finish. All right, so it is done. Now I have two machines, and both are up and running. Now I will open a new tab here, like a desktop, and connect with both machines, and I will put it side by side. So I will copy this, RDP, put the IP address, click connect, put the credential, NITAADMIN, Password 1234. Okay, yes. All right, I'm gonna right click here and yeah, smart sizing so that I can resize it a little bit. Here, first machine. How about second machine? Copy it, RDP, paste it. Four, enter, yes, and now wait for it. Second machine. Now I will just wait for both machines to log in and yeah, just spool up properly. Then I will move ahead. But in the meantime, let's recap. We learned what is network, how to create a network. We learned how to create subnets. Then we learned that resources can use those network in order to communicate. And for that, we created a virtual network and assigned the IP addresses. Now, if I go back to my resource group, click on my resource group and click on resource visualizer, here, I know it looks like a mess. Let me tidy it up. Just give me a second. Okay. All right, look here. So this is my PC. This is the hard drive for all operating system. So computer and the hard drive. This is NSG, which we don't know yet, like what it is, but just remember, NSG is for security. It allows the traffic, or it denies the traffic to pass through ports. All right, so if you want to block remote desktop, you can block that port. So this is for security. We will learn it later. Now, this is our network 1, 2. They are not connected. This is the public IP for my machine. So from this public IP, we are connected to machine number 1. From this public IP, we are connected to machine number 2. And we did that via RDP because NSG allows the RDP to pass. We open the port. Okay. Now, if this machine number 1 wants to talk with this machine number 2, well, they cannot, because the communication cannot jump between these two virtual networks. They are not connected. And we can test that. So I will ping another machine from the first one. And before that, I will also turn off the firewall for this machine because ping will not work, because by default, ICMP packets are blocked. Now, don't turn off the firewall for the real world. I'm just doing it for demo. In real world, you always create port rules to allow some traffic to pass from firewall. But anyhow, so let's go to firewall. Let me quickly disable it. No need to focus on this part. Go to property for this one, then open this and turn it off. So I will pause the video, turn off the firewall, and I will come back. Or I'll just show you this. I'm just turning off firewall like this. Over here, off, private, off, off. Actually, private is recommended. It's a private network. Okay, done. Same thing goes for this one. Advanced settings. Then go to properties. Come on, it's pretty slow. Okay, off, off, off. Apply. Okay. Done. Now I will open CMD. CMD. To get the IP address of this machine, I need private IP address because these machines will talk privately. They are not going through public domain. So I will type IP config. And I know if this is the second machine, the IP address will be 172.16.0.4 because 0.0 is the network address, it is reserved. 0.1, 0.2, 0.3 is also reserved in Azure, and 0.255 is also reserved. So the first available address is .4. 172.16.0.4. Perfect. And for this one, it will be 10.0.0.4. Here, 10.0.0.4. Now let me ping 172.16.0.4. It will not work. That is obvious. Now we can check out how to connect to networks. Now I will go to the network. You can click on any network because peering is done both ways. So there will be two connections created from VNet 1 to VNet 2 and then VNet 2 to VNet 1. So what is VNet peering? It's a process of connecting to Azure network no matter where they are. They might be in a different region, might be different subscription, different tenants, different resource group, doesn't matter. The only catch is you can only use Azure VNet peering process for Azure VNets. That's it. You cannot use Azure VNet peering to connect Azure VNet with AWS VNet. You cannot do that. So you go to the network, click on settings, scroll down, click on peering. Then over here, you click on add. This is where you put the name of the remote link. That is the opposite one coming from the other side. So I will call it VNet 02 to VNet 01. I named it so that you can understand the flow. You select the other network. So it is coming from 2 to 1. Then you can allow or deny the flow of traffic. You can make it one way if you want. This is the another link. VNet 01 to VNet 02. It's coming from 1 to 2. Click on add. When you add, you will see that two networks or two connections were created. It will show up over here on the right-hand side. Here, two connections are being created. Right now, it is not syncing, means it is not connected. But once both are finished, you will see the status will change to connected or successfully synchronized. Here, fully synchronized. Let's go back and run the command again. And here you go, we are connected. Ping 10.0.0.4. We are connected. So that was your peering, and I hope now you know what is virtual network, what is peering, and how to create it. All right, so now we will check how to create routes in the route table, and also how to troubleshoot your network environment with the help of the tools provided by Azure inside your Network Watcher ecosystem, Network Watcher dashboard, I can say. So I have a resource group, then I have two networks, in which I have two machines, then I have two public IPs for both virtual machines, and both networks are also connected. So if I show you the visual representation, as you can see, let's refresh it. Just focus on these two things. Your networks, they are connected. And this is why this machine can talk with this machine. We also tested that. Now, let me show you something. By default, whenever you create a machine in Azure, well, the DNS service, as well as the not HDMI, the DHCP service, DNS and DHCP service is provided by Azure. You don't set it up. You don't have to. Plus, Azure also give internet access to every machine by default. So there will be a default route which takes this machine to internet. And we can check that. If we go to browser on both machine, let's say, you have to go with this initial configuration every time I create a new machine. And then they say, like, why do we love Chrome? Come on, Edge. Like, so much stuff just to start. Okay, now let's see. Google. Yep, works. I don't need to surf internet here. Google. Yeah, I can go to internet on both machines. Now let's go to the machine. Before I show you how to create routes and how to put your custom routes there, I would like to show you something. If you go to VM, then click on Network Settings under Networking, then click on your network card, then go to Help, and click on Effective Routes. You will see the default route, which is there. And your machine must be enabled if you want to see this. Here you go. So if this machine wants to talk with anyone in 10.0.0.0/16, it will go to virtual network. Now, if this machine wants to go to any other network, let's say in the internet, any public IP, it goes to internet. So this is also active. These are all the routes. Plus, if this machine wants to go to 172.16.0.0/16, it will go to the peering. Remember, we created a peering. So all the routes are there now. Now, what if you want to change this route? Well, you can. So here I want to create a route and put it on the first machine to block internet, or to say that I want to terminate this route. This machine cannot go to internet. Let's do that. So to create routes, you go to Route Table. So what is Route Table? Route Table is a service where you create or define routes and assign it to the network interface, right, to make sure that the machine or the resource follow the given route. It basically defines the next hop. If I have to put it into a simpler language, I will say route table means it will tell a resource that, hey, if you want to go to a specific destination, you have to go to this hop. And that hop will be defined by you. All right, so create a route table. Select your resource group, Canada Central. Name it my demo R. R stands for route. And propagate gateway routes. Yes, I will say yes. And if you are going to create multiple networks in the future and then connect them and create a complex mesh of network, you want this route to propagate automatically to all the connections, right? So I will say yes. No need for tags. We already learned what tags are. Create. Now, creating route table is not enough. You have to configure it. So once my route table is created, I will go to my route table. If you don't see it, just go outside, like out of the service and go back. Yeah, here you go. Click on it. And then go under setting, click on routes. This is where you define routes. So click on add. Route name to internet. No, you cannot go. Okay. Destination type, IP address. This is where you type the destination IP address, or let's say you want to type the range where you assume this machine wants to go. Now, if it is a specific IP address, you will type that. But if you want to type all the possible IP addresses in the world, well, you want to capture or cover every IP address. In that case, you will put a wildcard. So to select all the IP address, the wildcard is 0.0.0.0/0, means any IP address. Okay. Next hop, internet. Right? Now, what will I do here? If I say internet, basically what I'm doing is I'm creating the same route which already exists there. So instead of Azure doing that, I will do the same thing for like on my own. No, I will select none. If I don't want this machine to go anywhere, none. Click add. So a very restrictive route is now created. Now I need to assign it to a subnet. So I will associate this route with my network and subnet. Click OK. Now, once you do this, if you go back to your machine, you may want to give it 10, 15 seconds, right? We just applied it. Let's go back to our machine, go to network settings, then go to our network card, and scroll down under help, click on effective routes. You will see that the default route will become invalid because there is a custom route which you created. So if a custom route, see default route 000 internet invalid, user means custom route or user defined route is now active 0000 to none. So if you do this, custom routes always trump. Okay, refresh. And I lost my connection with this machine. Of course, this machine cannot go to public internet anymore. Now, how will I test it? Remember, I stopped this machine from going to internet. But there is still a route which is valid. That route is that machine can at least talk with the private network. So what if from machine number 2, let me ping it to show you. See, I can still reach this machine. So what if from machine number 2, I RDP to machine number 1, 10.0.0.4. Enter. And boom, we are connected. I mean, almost connected. All right. So right now we have inception, machine inside machine, smart sizing. As you can see, internet is still there. And if you refresh it, well, you will not go to internet. Maybe it will still show you Google page because might be it is saved in the cache. So close it and open it again and go to a random page. Well, you can see I cannot go to YouTube as well because obviously this machine cannot go to public domain because we created a route. Hopefully now you know the magic of route table. Very crucial if you want to create your own user-defined routes. It is awesome for security to create controlled routes so that the machine, which is super critical, can only go to a specific destination which is allowed by the administrator. So that was your route table. Now, what if you want to troubleshoot your network? Well, whenever you create a network, Azure automatically creates a resource group called Network Watcher. And inside this, you have what? Network Watcher. Yeah, type network watcher. Here you go. One is for Canada and one is for France. In the France, the network is pretty good. We did not create any route table to change the outcome of France ecosystem, but let's focus on Canada. So if you click here, all right, you will see resource visualizer. This is the network watcher. Let's go back to network watcher now. So if you go to network watcher, not inside it, just network watcher dashboard, you will see monitor, network diagnostic tools, matrix, and logs. Monitoring will help you to keep an eye on your network to make sure that network is properly connected, and if something goes wrong, then give you an alert. Diagnostic tools help you to narrow down the scope where you think the problem is so that you can fix it. Matrix will tell you the sensory data or the data coming from sensors, or you can say the real-time, I will say, performance matrix or numbers. Here you can see the usage quota. Logs will give you the historical logs for auditing purposes. But we focus on the tools. So if you click on topology, by the way, here you get the structure. And this is the topology of my infrastructure, as you can see. Two connections are there. Of course, there are two connections because it's paired. One goes from Canada to France, the other one goes from France to Canada. Okay, so if you expand Canada, it will dive deep. Then this is your network. I only have one network in Canada. I will expand it. There's a small plus icon. Click on it. It will show me there's only one subnet. Expand that. It will show me all the resources connected to that subnet. Remember, my public IP is connected to this configuration. This configuration is connected to my network card. NSG is connected to my network card. And my machine is connected to the network card. The network card is connected to subnet. So you see the whole topology. Very useful if you want to generate reports or diagrams and you want to explain a complex environment in an easy way. All right. Connection monitor. Well, you just create a connection monitor between two resources. What is connection monitor, by the way? It just connects, not connects actually. What it does is it allows you to test the connection between two resources. So it actually tests the connection between two resources in a periodic way. Every 5 seconds, every 10 seconds, means in a sequence. And whenever there is a break in the connection, means one resource cannot reach the other resource, alert will be generated that, hey, the connection is down. Traffic analysis. Here you can analyze the traffic between multiple resources. Again, advanced topic. If you want to learn all this, then the course is called AZ-104, that is Azure Network Engineer Associate. And for that, you can go to NetSoft IT Academy, NITA, NetSoft IT Academy, where we put all the in-depth courses. This is our computer-based training platform. All right. IP flow verification. This just checks if one resource can talk to other, means line of sight is there or not. So I can say, can machine number 1 from this network card, this is the local port is, let's say, 3389, that is RDP, can go to 16.0.4. Oh, no, sorry, 0.4, port 3389. So what I'm doing is, I'm just saying, can machine number 1 using TCP protocol for inbound port have a line of sight from this IP address through this port, which is RDP port, to this IP address using this port. You click on verify IP flow. And you scroll down and it says access allowed. That means line of sight is there. Brilliant. How about outbound? Can this machine go to that IP? Let's see. So instead of guessing that, okay, here's the problem, or check this, check that. No, for every troubleshooting, the rule is start from either end. Don't just check random resources to find the issue. Even if you know everything is configured properly, well, suppress the ego and start from one end. Just go through it. Yeah, allowed. Now let's see the outside world. So inbound, let's say. And the outside world is any random public IP, because it can be any IP. I just want to check if someone from public IP can get into this place. So I will just put any IP here. Why I'm just putting random? Because it will be a public IP somewhere. Okay, 3389. Let's verify. Why I did this? Because I can't give you my public IP. Access allowed. So inbound, you can. Now, what about outbound? Perfect. This is also allowed. So allow internet outbound. Both are actually allowed. So I also tried port 8080 to Google DNS. Again, inbound and outbound, both are allowed. But we created the route table, right? So why it is saying it is allowed? Well, basically, yes, the ports are open. The machine can go out to the internet from the Azure side, but at some point there will be a route table which will stop it. So if we go to next, that is the next hop. This is where we check, okay, so if I want to go to 8888, let's say, so what is my next hop for that? Well, I will select my machine 1, interface, source IP is this, destination IP is 8.8.8.8, and search for next hop. Right, so the next hop is none. So if I have to go to 8888, I'm not going anywhere. So over here, my route table will stop me. Now you know that there is something wrong here. I should go somewhere, right? So your routes are not correct. So in this case, you can go to your route table, and I'm going to remove it. You can also edit it to fix it, but just let's say disassociate. Perfect. Now let's go back to our network watcher, next hop. Next hop. Scroll down. So the next hop is internet. So I will go to internet. Right now, this service is provided by Azure, and you will not see the IP address of internet here. It's a backend resource. Let's say this machine is going to a firewall, then you will see the private IP address of the firewall. So this shows you the next hop. Now, what if you want to see the NSG rules applied on this machine? All the ports which are open. Well, you can do that. Subscription, resource group machine, and then wait for it for some time, and the associated NSG will show up eventually. Let me do it again. So showing only top 50 security rules. We only have few, so this scope is good enough. And here you go. So you see VM1 NSG, the one applied on it, click on it, and here you see all the inbound rules, all the outbound rules in its full glory. So request coming inbound from 0000/0 to 000/0 means wildcard. That means request coming from any place, through any port, going anywhere to any port is allowed. I know, not secure, but for demo, it works. And then these three are by default there. This actually allows for internal communication within Azure Virtual Network environment. So this is the custom one. Then what if you have VPN connections, site to site, point to site? You can troubleshoot that from here. Then, just like Wireshark, what if you want to capture the packets between two networks? So basically, it will capture the traffic going between two networks, and then that data can be used to investigate, to find the bottleneck issues, or maybe to audit something which is happening in your environment, maybe an attack. And this is connection troubleshooting. Source type machine, virtual machine number 1. Destination type is, again, select a virtual machine. Machine number 2. Preferred IP address, both. Destination port is, let's say, 3389. Source port is 3389. Diagnostic test everything, run diagnostic. So this will test connectivity, NSG diagnostic, next hop, and port scanner, and give you a report. So the sum of multiple tools together. And then after some time, a report will be generated, which you can also download. See, connectivity test reachable. All right, so yeah, I can reach this machine. Everything is open. Latency is also mentioned. Outbound NSG diagnostics allowed. Outbound communication via this port, that is RDP, is again allowed. Inbound NSG diagnostics, deny. Next hop, source, successful. Next hop is virtual network peering. And route table is there. That is system routes. No custom routes are being used because I removed it. Source port accessible, reachable. So between these two machines, VM1 and VM2, this is the report. Then you can even see details if you want. So that was Network Watcher, and with this, I will say demo is also over, and I hope that you now remember how to create networks, public IP, how to peer it, how to test the communication, how to create route table, and I will encourage you to go ahead and create your own environment and test it. All right, so in this video, we covered how to create and configure VNets and subnets, set up VNet peering, configure public IP addresses. We also saw how to apply user-defined routes. Plus, we also saw how to use some tools to troubleshoot network connectivity, and these tools are provided by Azure. Next up, we will look at how to configure secure access to the virtual networks, including NSG, that is network security groups, service endpoints, and private endpoints. So make sure that you stay tuned, and I will see you in the next one. Take care.
Thank you for watching NetSoft IT Academy. 905-812-2923. info@netsoftacademy.com. www.netsoftacademy.com.